Welcome back to Math 106, Technical Math. And today I'm going to talk about the unit circle and also incorporate what we need to know about radians and converting radians. So let's get started. What you see on the screen right now is the Trig tutorial handout that's in the module. And on the first page, we see a reference to radians, and radians are sometimes used in calculations rather than degrees. And I'm going to talk about that when I talk about the unit circle. So if we head on down to actually the last page in this kind of trig cheat sheet that I've put together for us, we see this thing called the unit circle. Do not let this intimidate you. You can totally handle it. It's not that scary once you understand what it is you're looking at. When you first glance at the unit circle, it looks sort of intimidating, but I'm going to walk through it so you can understand it. All right, so I'm going to jump over into a different screen so that I can actually draw on the unit circle, but this is the same unit circle in your handout. Okay, so what you see here, let's just talk about what it is we're navigating, okay? One thing to notice right out of the box is this is 0 degrees and 360 is right here at this point right there. So that's important because we need to recognize that 0 starts here. We go around up to 90. We go back down to 180. We go around to 270. And then we go around again all the way up here to 360. So one trip around takes us from 0 to 360 degrees. That's probably not terribly shocking to anyone, right? But that kind of measurement, which is degrees, has nothing to do with the size of the circle, right? So what we have is we have studied this already quite often. We have talked about the circle having a relationship to pi and the radius. That relationship that we've used is circumference. So circumference, we have said several times in here, is a special word for perimeter of the circle, and the circumference is equal to 2 pi r. Well, that means 2 times pi times the radius. Okay, so the radius for the circumference of a circle changes, right, with the size of the circle, because circumference, again, is if we had a little stick person. You know, I like stick people when I talk about trig, a little stick person, and that person walks around the edge of this circle and follows the edge all the way around, and that's essentially the perimeter of the circle. And it's how far would we travel if we walked all the way around the circle, like all the way around the globe, if we could keep it in a perfect circle. So that is circumference. So the unit circle, right? The unit circle is a very special circle, very special, because the unit circle is referring to a circle that has a radius that is equal to 1. That is very specific and very special. So if we have this relationship that the radius is 1, that means that anywhere that goes from the center of the circle to the outside of the circle, anywhere we do that in a straight line, we have a known distance, because that is going to consistently be 1 no matter where I place it on the circle. We're going to have 1 here. This is 1. This is 1. I could even put a 1 down here. I don't have to land on the dot. I could be, as long as I'm on the edge of the circle. That's 1. They're all 1. Well, that gives us a very unique situation where we basically can experiment with all the other combinations because we're holding the radius at a constant of 1. Shoo, okay. If this gets a little fuzzy, don't worry about it. Just keep going and listening, and hopefully it will start to make some sense. So if we have our circumference equation here and we plug in our knowns, we would have 2 times pi, right? Times, for the unit circle, that would be times 1, because we've held our radius to 1. Now, for the standard unit circle, units don't matter, like inches or feet or centimeters or meters or miles or kilometers. As long as they're linear, it could be anything. So if it helps you to think of this as 1 foot, for example, then go ahead and think of it that way. But really, it's not referring to 1 anything. It's just referring to the number 1. Well, what we get up here then, if we have 2 pi r and we plug in, so we have 2 times pi times 1, what we get is 2 pi, right? Because the 1 just kind of disappears. So we're left with 2 pi. This is significant. I'm going to clean up my picture a little bit so we have a little more room to move. This is significant because now we have an equivalency for the circumference of a circle if the radius is 1. So let's see how this works then. So that means that if we start here and we go all the way around the circle and we come back again, all the way around and back again, that we have gone 360 degrees, right? We've gone from 0 to 360. Well, on the unit circle where the radius is 1, we have started at 0 from the circumference, and we've gone around a length of 2 pi. Because if I go all the way around and back again, the circumference, not the degrees, but the circumference is 2 pi. So you see right next to it here, we have 0. So 0 equals 0. And we also have that 360 in degrees equals 2 pi in distance, right? So that's important because here's the deal. The circumference, when we change the radius, right? Let's say, for example, we decide that radius isn't 1 and we change the radius to, let's say, for an example, we change the radius to 2. So my radius becomes 2. Well, now we've changed this whole relationship, right? And this means that if we drew a radius, that this is now 2. That would give us a circumference that was double what the unit circle was. Now, let's think about the degrees. If we change the radius on the circle, do we have more degrees? Did we double the degrees in a circle? Does it now go from 0 to 720 to go all the way around? Well, no, right? No, absolutely not. Any circle, no matter what the radius is, has 360 degrees. That is a constant. But the important thing to recognize is that the 360 here has no relation to the size. No relation to the size of the circle. This is the symbol for circle, right? So 360 doesn't tell us anything about the size of the circle. Circumference tells us about the size of the circle, right? Because that tells us how big the perimeter is. How big is it all the way around? So something as small as a nickel would have 360 degrees in its circle. Something as big as the Earth would have 360 degrees in its circle. But the distance changes, and that's where these 0 to 2 pi comes in. So when we switched over to the 0 and the 2 pi, the 0 and the 2 pi here are in a different unit. So I'm going to get rid of the r equals 2 because that was just to explain, and we don't really care about that. And I'm going to get rid of this. And we're going to talk about this 0 and 2 pi a little bit longer. So the 0 and 2 pi here that are distant is a distance around the circle for the unit circle are in a unit called radians. So this is 2 pi radians. It's written as RAD, that's the abbreviation. And radians are a unit that is somewhat, can be equated to degrees. So we can convert degrees and radians back and forth, but it really is its own deal. And what radians does for us is it translates the angles. So angles come from the center of the circle, right? These angles go out to the side of the circle from the center to the side. Well, it translates the angle and projects whatever the angle is to the outside of the circle and translate then what the distance would be given how far we traveled on the radius. Shoo. So the radians is based on the radius of 1, and this is telling us the translation from the center of the circle out to the outside of the circle. So we could calculate, for example, a sector, which is what I covered here in blue, which is a like a pizza slice or a piece of pie. Sector. So we won't spend a ton of time in radians, but it's important to understand that they exist because sometimes we run into them when we're dealing with angular measurement. So we'll look at how to convert those between the two systems here in a little bit. We're already pretty good at that, and we'll use brackety thing to do it. Okay, so let's keep going. So you also see coordinates and the Cartesian coordinate system on the unit circle. So what I mean by that is you see, let's go with purple. You see an X here and you see a Y here. So we have X and Y axes. So X is the horizontal axes and Y is the vertical axes here. And that's important because that gives us coordinate system. So what we see here is right here, this dot at 0 and 360 or 0 and 2 pi radians has a coordinate of 1, 0. I'm going to blow that up a little bit so we can see it, right? It's 1, 0. Well, that is the order matters. That is X coordinate, comma, the Y coordinate. And it's always going to be in that order. So anywhere you see on this circle that there is a coordinate given, then you see that you are being given X and Y. So here we're at 1, 0, positive 1, by the way. That means that we have gone 1 unit, which makes sense because we know that the radius is 1. And if I go straight across here from the center, I've gone 1 radius unit, right? So that's 1, distance of 1. So my X is 1 because I've gone in the X direction horizontally. Well, Y is 0 because I did not go in the vertical direction at all, right? So I'm at 1, 0 here because X is moved in the direction of the X by 1 unit, and Y has traveled in the Y direction 0 units because we haven't gone up or down. So let's pick a different one that's not, well, actually, let's look at Y real quick here. So Y up here, you see, has reverse coordinates. So up here, I have 0, 1. This is 0, 1. So remember, X, Y is specific. That's the order. It's always going to be X, Y. The X then is 0. Well, that makes sense because here at this dot, we have not gone left or right in the horizontal direction at all. We have gone straight up from the center of the circle, straight up in a vertical line. So we have not traveled in the X direction. We've only gone in the Y direction, which is straight up, and we've traveled in the Y direction by 1. It is plus 1 in the up direction. Okay, so then if we look over here on the left-hand side, we see that we have a -1, 0. Well, that's my x, y. This is because I have gone to the left, which is the negative direction, straight in the x plane. So I have gone horizontally a unit of 1 in the negative direction. And I haven't gone up or down, so I haven't moved in the y direction, so it's 0. And then we see the last one down here on the south pole is x, y is 0 in the x because we've gone in a straight vertical line down, and it's -1 because we've gone negative direction for y, a distance of 1. All right, so that's the coordinate system that we have here. So then let's look at some that don't fall in a horizontal or vertical plane. So for example, let's pick 60 degrees here. So I go from the center out through a 60-degree angle to this dot right here. Now the 60 degrees, I'm gonna erase this to get it out of our way. 60 degrees is this. This is now 60 degrees from here to here. Okay, so that represents a coordinate. Here's my x, y coordinate of 1/2, 3/2. Well, how is that possible? Well, the x is referring to how far we traveled in the x direction. So if I drop this straight down here, this from the center to here is 1/2. That's x. Y is the square root of 3/2. Well, that's in the y direction. If I go over here and figure out where I intersect with y, I have gone from here to here in a vertical direction, the square root of 3/2. All right. So that now is telling me how far I traveled in each one of those directions. And then if I figure out where those lines cross, I end up on this coordinate on that circle in a very specific place. I have also just constructed a thing called a right triangle, right? So I could put a little right triangle there. And now I see that I have these side lengths. So let me circle those in a different color so we don't lose them. My y side length for my triangle is the square root of 3/2. That would be this side here, right? My x side length is 1/2. And I could convert those to decimals pretty easily, right? So they don't have to stay fractions. But that's giving me a triangle that has 60 degrees. I know that the bottom side, this side down here is 1/2. I know that the tall vertical side is square root of 3/2. And I also know that the hypotenuse is 1. How do I know that? Well, it's the unit circle, and the hypotenuse is a radius, right? The hypotenuse is going from the center to the edge of the circle straight out. Well, that is a radius, so that would be 1. So I know everything I need to know about this triangle. So here's the part that's kind of crazy to help you understand where trig comes from, which is the whole point in me showing you the unit circle to begin with, is just to demystify trigonometry and to help you understand that the triangles really come from a circle. I know, weird. But here's the deal. Down here at the bottom, we see that for any ordered pair on the unit circle x, y, like we've been dealing with, cosine of the angle is the x coordinate and sine is the y coordinate. What? That's fascinating. So what that means is the sine of 60 degrees and the cosine of 60 degrees is equivalent to the xy coordinates. So just like it says, cosine is equal to the x coordinate, and back up. Cosine is x, sine is y. Well, that's pretty interesting. So that means that the sine of 60 in our example here is equal to the y coordinate. Well, that was square root of 3 over 2. So the sine of 60 is the square root of 3 over 2. The cosine of 60 is equal to the x coordinate. Well, that's 1/2. So this is equal to 1/2.